Let's solve LeetCode 150 evaluate reverse Polish notation. So we are given an array of strings tokens that represent an arithmetic expression in a reverse Polish notation. What is reverse Polish notation? If you go over their Wikipedia, reverse Polish notation, also known as reverse, I don't know how to pronounce this notation, Polish postfix notation, or simply postfix notation. You might have studied this in your classes, is a mathematical notation in which operators follow their operands, in contrast to prefix or Polish notation in which operators precede their operands. The notation does not need any parentheses for as long as each operator has a fixed number of operands. So what does this mean? If you take a look at their example 34 plus, what does this mean? It means that we're trying to do 3 plus 4. How? Well, I'd like to show you something. So the reason we say 4 plus is equal to 3 plus 4 is because you encounter the first operand that you have. So, when you encounter the first operator that you have, you just take the plus and then you take the last digit. So you just take that and then the first, like the digit before it. So the number that's before 4 and then the number that is before 3, you take the last two digits and then you just use the operator to do the operation, which gives us 7. So this is like what postfix notation means. If you want to find out how that's useful, you can scroll down. But remember, if you look at the explanation, you'll essentially get the answer to this question. So how do we solve this? But before even going forward, I would like to show you this. Evaluate the expression, return an integer that represents the value of the expression. So essentially we will be given a list like this. We want to calculate the output. The valid operators are plus, minus, asterisk, which is multiplication, and forward slash, which is division. Each operand may be an integer or another expression. The division between two integers always truncates towards 0. There will not be any division by 0 because that's undefined. The input represents a valid arithmetic expression in a reverse Polish notation. So we can always be sure that we are given an actual valid Polish notation or reverse Polish notation. The answer and all the intermediate calculations can be represented in a 32-bit integer. A 32-bit integer basically means that you can have minus 2 to the power 32 till 2 to the power 32 values. And here is our input. So the tokens are 2, 1 plus 3 asterisk. Let's do it ourselves. 2, 1 plus 3 asterisk. How do we solve this? So what happens here is that we do 2, as you can see in the explanation as well. You'll have 2 plus 1. The reason you'll have 2 plus 1 is because as soon as we see an operator, we take the previous two elements, cool, and then we perform the operation. Then again we see another one, so we take 3, okay, do the asterisk, so that is the multiplication, and do it with the number that was previously computed, so the number of this operation, so which is 3. So 3 into 3 will give us 9. That's how it goes. Let's take another example. Let's say we have this thing as our input. Cool. How do we solve this thing? So the very first thing that we need to do is find out the operator, right? So division. Now I need to calculate the division between the last two elements. So I have the division between this and this. So what I'll have is 13 divided by 5, correct? So whatever is their output, let's say the output is 2 because it's going to be a 32-bit integer. We just float it down. And then we do, so this operation gives us 2. So you can essentially remove these two. You have 2 now, okay? And then you have a plus. So what you do is plus 2 and then you take the previous element, so 4. So this gives us 6. What I've done here, I think you've understood this, but you might not have understood what I did with the plus sign. So as soon as we see the next operator, we take the previous two elements. The previous two elements are 2 because that's the one we calculated here, and then 4. And then we add them up, so we get 6. And that's why our answer here is 6. If you want to try this out, you can give it a shot. But my question is, how do we solve this? Well, to solve it, what we need is previous two elements. We always need to keep track of the previous two elements. So as soon as I go over here, I see an operator. I need to identify that it's an operator that we're talking about. And then I'll just take element before it and then the element before it, right? So let's say this is I. So I'll take I minus 1 and I minus 2, correct? But the problem I have with this is, let's say we resolve this. So we do 13 divided by 5, which gives us 2. So how do I remove all of this and ensure that plus, which when taken as I, will give me 2 as I minus 1 and 4 as I minus 2? Like, we need to adjust that, right? And to adjust that, what we can do is use a stack approach. How would stack help us? Let's say we have a stack like this. So what we do is store numbers here. As and when we get numbers, we store it. So we get 4, 13, and 5. This stack will only contain the numbers. It won't contain any operations or operands as such. Because every time we see like any operator coming in, what we'll do is find out the topmost element. So the element at -1. And then I'll find out the element at -2. And then I'll just do the element at -2, which is 13, divided by 5, which will give me 2. Also, I'll pop these off. So I'll remove this 5 and 13. And then whatever answer I get, I'll append it to the stack. So now 2 is in the stack. Cool. So these two don't exist anymore. What we only have is 2 and 4. And then we go to the plus one. So as soon as we go to the plus operator, we get -1, which is 2, and -2 is now 4 because none of these exist. And that's why we'll get 2 plus 4 done, which is equal to 6. So that's how easy it is with a stack. But there's another consideration that we need to keep in mind, and that is, what if the number is a negative number? Will it work? And yes, the answer is yes, it will work. But the only problem is, how do we identify a negative number? And we'll look at that in just a minute, but let's go ahead and create a stack. After that, I'll go over every token that is present in this tokens list. And then I need to figure out if it's an operator or an operand. So I need to figure out if it's a number or if it's a operator. How will I check that? I can just use, hey, if the token is alpha digit, I think that's what it's called. You can ask your interviewer about this if you can use this function, which is Python is alpha digit or something like that. Not is alpha. I think it's is alpha. That's it. Cool. So we can just use this. And actually, we don't want to find out is alpha. We need to find out is digit. So we can just use is digit. But the problem with is digit is that it will only recognize positive numbers. It won't know that a negative number is a digit. So even if you use this is digit function, and you can look at the Python documentation to figure out how to use this, but essentially what we need to do is math.isDigit, I guess. And actually it's just text.isDigit. My Python is not so good, and I don't think your interviewer will punish you for it. So if token.isDigit, then what you want to do is, well, it's a number, right? So you want to convert it into a number and append it to a stack. But there's another thing. I told you just now that isDigit doesn't catch negative numbers. So we need to catch it ourselves. And the only reason, by the way, we are doing this is because this is all strings, okay? Now, to find out negative number, we can just check that, hey, token at 0, if it is equal to minus, that means the very first thing that we have is minus in this string. It means we have a negative number. And if the length of this token is greater than 1, then for sure it is a negative number. Because if we just check that, hey, if token is equal to negative or minus, you're saying that you're checking for an operand, or sorry, an operator, but we want to check for an operand, right? So you have to check just the very first character if it's minus. And if the length exceeds 1, it will be a number. For example, if you have a string like -2, okay, it has 2 characters in it. But if you just have minus, this is an operator. And if you use this operator, it's going to be, well, not a number, and it will error out. So this is why this check is also put in. And yeah, once we do that, we have found out the digit. So we'll just have digit is equal to int of token, and then I'll append to this stack. So I have stack.append digit. Cool. Now, if this token is not a digit, and by the way, here we need to put or, because token is digit, or if this is the case, that means it is either positive or a negative number. That means it is a number. And if this is not the case, then we have an operand with us. Sorry, an operator. I don't know why I'm getting confused with it. This is an operand. Now if we reach the else condition, we've reached an operand. And if we've reached an operand, we just need to get the -1 element and -2 element. So what I can do is stack.pop, that will give me number 1 or element 1. And then I can do element 2, which is equal to stack.pop again. Cool. So what I'm doing is popping out this element, popping out this element, and trying to get both of them. And once I do that, I can perform the operation. Now, what operation do I want to perform? Well, if it's a plus, addition. If it's minus, addition. So we just have to check that. Hey, if the token is equal to minus, that means we want to do element 1, or actually, I don't know if we want to do what. So when we had 13 divided by 5, we took -2. So the element 2 minus the element 1, right? So I think that's how it goes. And then you can just append that to the stack, I believe. So yeah, stack.append element 2 minus element 1. Now, if the token is equal to positive, in that case, we will do stack.append element 2 plus element 1. If the token is equal to asterisk, in that case, stack.append element 2 multiplied by element 1. And finally, if we have division, we can put else or elif, whatever you want. We can just do stack.append element 2 divided by element 1. I could only do else over here because they've told us that it will either be 4 of these operations or an integer. We've got integers here. So if it's not these 3 operators, it's going to be the division operator. Cool. So having understood that and having the code for it, I think we're all set. So we can go ahead and just have something like this done. So by the end, we are expecting that, hey, all the tokens have been completed. Now we only have 1 element in the stack, because what we have done is after we did 2 plus 4, so the last element here plus this element here, we got 6 and we appended it to the stack. So what we want to do is return the element that is present at index 0. So we have return stack at index 0, right? And that's pretty much everything. So let's run it and see if that works out. And it says cannot access local variable token where it's not associated with a value. And let's see where that could be. Oh yeah, we have to do for token in tokens, not for token in token. Now let's run it. And we get a wrong answer. We get a 6.6 over here. How are we getting decimal operations? We're getting decimal operations because when we divide, because that's the only part where we can actually get decimal values, right? Because if you divide 13 divided by 5, it's not equal to 2. It's actually equal to 2.6, I believe. So what we want to do is floor division. So instead of doing just a division here, we'll do floor division with 2 backslashes or forward slashes and then run it. And then I believe it will work out. So this gets resolved, but this still doesn't. The answer here is 22. And again, we run into an error, and that's because, again, related to this division. I told we need to do floor division, and floor division only works when we have, you know, just the positive values. For example, if we have 13 divided by 5, it will work fine because it will round to 2. But if we have minus, let's say, 13 divided by 5, then what will it round off towards? It will round off towards minus 3, not minus 2. The reason for that is minus 3, the floor division essentially tries to take the lower value, and minus 3 is lower than minus 2, right? So it will give out minus 3, which is the wrong answer. And that basically messes up the entire calculation. The question specifically tells us that the division between two integers always truncates towards 0. So what we want to do is not always get the minimum. We ultimately want to truncate towards 0. So what we'll do instead is just divide it normally, but after dividing it, we'll convert it into an integer, and that will truncate towards 0. So if I run this now, it works out, and then I submit, and that works out as well. So the time complexity here is O of n, because we had to iterate through the entire array. And the space complexity here is O of n as well, because we have to maintain a stack.